Thank you so much. Honored to talk today about AI and workflow support and lung cancer screening. The challenges are known. We have an increasing number of scans. Alone in the US, 14.5 million people are eligible to get a yearly scan. And at the same time, you have limited resources. So radiologists need to read more and more images. And the targets for us as a software development company should be to improve the diagnostic quality, at the same time reduce the reading times. At first, what helps a lot is an I-ELCAP. You want to detect the nodules, you want to analyze them, do the segmentation, everything automatically. And it is out of question that the AI is the star within the software family these days. But you should not forget about the very often overlooked siblings, that these are the little tools and the workflow solutions which really makes you read faster than in the end. Let's talk about the cat first. So why are radiologists overlook or do not report some nodules? There are certain errors that can happen. You never looked there, you looked there but didn't see it. You found something else and stopped looking because there was an obvious nodule and so on. And with this, the I-ELCAP can help to improve the efficiency of reading. And then there are characterization errors, and malignancy risk estimation models can help in this regard here. The Violety lung cat is our AI cat for the nodule detection. It's based on a machine learning model, segments the nodules, gives the location, diameter, etc., the density with a high sensitivity and low specificity. And what you want to achieve with an algorithm is always, and you have to kind of balance the sensitivity and specificity. You want to avoid to get too many false positives, which is very disturbing during your daily read. Referring to the first two speakers, we also did measurements on the images with the 3 different G scanner settings, the images from the Acumitra Phantom, and we could show that the improvement also with our system is very significant and visible here. The Violety lung read is the all-in-one reading solution, and we think besides having an AI, you also need the possibility to interact on AI results. And that's what we can do with our solution here. So as a radiologist, you read the chest CT slice by slice. You mark and segment nodules manually or with the support of CAT. And rule of thumb should be that at first you mark your own findings and then ask the CAT. You analyze the nodules over time. So this is also very helpful, are these elastic registration algorithms that help you to propagate the findings from the prior scan to the current scan, so that you do not have to do that manually, and then automatically the volume doubling times the growth rates are calculated. In the end, you want to produce a guideline compliant report. And if you have all of this together in one system, we did a study which could prove a reduction of reading time by 47%. So you read much faster, but only if you have everything together in one system. Evaluating a little bit on the reporting guidelines and how software can help, these are the ACR lung rats guidelines. It's a decision tree that you have to go through, and software can help. You need the calculator. You do not have to do it in your head. The software makes a proposal, and you can overrule always. You can change the decision, but you do not need to calculate it in your head. Even more complicated are the BTS guidelines. And look at these decision trees and imagine that you have to go through that for every nodule on your own. And again, software can help. Our system can do that and do this per nodule. This is a per nodule module. And do the BTS guidelines in this regard here. Last but not least, the I-ELCAP reporting guidelines. We have an integration with Screening Plus, and Screening Plus does the calculation for us and sets the staging according to these guidelines there. Another model that software should support, and also we are doing, is these are the malignancy risk estimation models. And the well-known Brock model, also known as the PanCan model, is a model that's based on various factors, but it's only for a baseline scan. It does not consider volume growth and the comparison between prior and current states of the very nodule. This is the equation here and the factors. So a lot of factors also outside of what is visible on an image go into this model. And then there's this formula. And the way we solve this, so we give it with every nodule, we give the malignancy score here. And we introduced like a color scheme, red, yellow, green. It's more the European traffic light. I know that in the US there's no yellow. The Brock score is used within the BTS guidelines, so you have to have it to calculate the BTS recommendation for every nodule. The ACR lung rats version 2022 also refers to using this model. And in British Columbia, obviously, and in other parts of Canada, they are using this model. I also learned, because we are engaged globally, that Australia wants to do a screening where the baseline scan is only considering the Brock model. And then if the malignancy risk is low, they will do switch to the ACR lung rats and do a 2-yearly scan of this very patient. Last but not least, the future is that AI algorithms take over, and they will consider also volume doubling time, etc. And so we are engaged there, and there are some promising results already. And we think a lot of these systems will have FDA approval sometime, and then you have an additional tool to help in your daily work. And this is the end of my talk. Thank you so much.